Okay, so let's ask another question about this collision. So what is the change in momentum of the smaller player? And when we know that the original momentum of the smaller player, which we calculated 2 frames ago, was equal to his mass, which was 90 kilograms, times his original speed, which was 8 meters per second. And so this was 720 kilogram meters per second. And we know that the final momentum of the smaller player now is equal to that same 90 kilograms, since his mass doesn't change. But now he's only traveling with the speed of the pair that we just calculated on the previous slide, which was 0.9 meters per second. And so his final momentum is 81.8 kilograms meters per second. And so we want to calculate change, so let's write these as vectors just for the sake of argument. And so the change in the momentum of player 1 is equal to P final of player 1 minus P initial of player 1. And so this is equal to 81.8 minus 720, which is equal to approximately minus 638 kilograms meters per second. So that's the change in momentum of the smaller player. Now, we can check this because this should be the same change in momentum as the magnitude should be the same as the change in momentum of the bigger player. And so we can go and switch to the bigger player here. So the initial momentum of the bigger player, so P initial 2, is equal to minus 520, and P final 2 was equal to, it's going to be 130 times the new velocity, which is 0.9, and so that's equal to 118 kilogram meters per second, keeping with our units here. And so the change in momentum for the big player, so delta P2, is going to be equal to 118 minus a negative 520. So this is going to be equal to 638 kilogram meters per second. And so it is true, in fact, that the change in momentum of player 1 is equal to minus the change in momentum for player 2, which has to be true if the total momentum of the system is constant. So this was useful to calculate, and then it's useful to cross-check and make sure that if we do the same thing for the second player, we get a negative of the first answer so that the changes are equal and opposite.